basics. So meaning that we try to introduce basic control system. What is the block diagram of the system? What is the purpose and method? Is that our control system manual or automatic? Or our system components? What are the components involved in the control system? And also type of control system. So problem of control system, maybe open loop, maybe closed loop, and so on. Okay, so we go to the basic definition of control system. Okay, so when you have draw your system, so hopefully your system can be draw as a block diagram. After that, the block diagram meaning that our system is designed built up with a few subsystem. So with a few subsystem and processes. So meaning that your signal input goes to maybe amplifier, the output will be amplified and then go to filtering process. This is the process. So many subsystems involved in the one complete control system. Assemble for the purpose of obtaining desired output. So meaning that we try to get what is the set point of your output. When you set the temperature of your room to be 20 degrees, we must get that 20 degrees. Okay, so our system follow our set point, our desired output. That is the control system. Actually, what we need is our system follow our desired output or our set point. So from that we can study, we get the performance of the system, maybe accurate, maybe not accurate, maybe equal to the set point, your desired output, or maybe different. So you can get the performance of the system. So in general, we can draw your system into blocks. So the first block here, this is your set point actually. Your input to the system is set point. You set the speed of your fan. You set the temperature of the water heater. That is input signal. Input signal that we set to our system, and the first part we can call as controller. Controller can be amplifier, can be attenuator. That is controller to control the signal. Then output from the controller goes to the actuators. We call actuator something that heat up your water, something that valve to open the valve and water flow in, maybe motor. So that is the actuators. So we can combine, maybe your subsystem 1 can be controller, your subsystem 2 can be actuators, maybe valve, maybe motor, maybe heater. And the final part is your process that we call plant. So this one, you measure back what is your output. Your process plant. The plant itself is your maybe your room, maybe your output of the water, level of the water, the tank itself. That is the plant. We call that plant. And your output is your desired output. Maybe if your system is to control the temperature, your output will be temperature. So maybe your output is the level of water. Maybe flow of water. So whatever output that we need, that is the actual output of your system. Actual speed of your fan. That is the output from your system. So your system should consist of input signal, that instruction that we give to the system, input signal, and inside your system we have a few subsystems. So maybe you have controller, amplifier, attenuator, filter, so we call it here. So maybe you have a motor, valve, heater that we call actuators. And finally, this is your plant itself. All the component involved, we call that process of plant. So this is the component of control system. The basic component of control system. Okay, can you follow? Okay, so maybe actually I've discussed this one. So we try to, the aim of the control system, regulate the certain variable, meaning that we regulate the power to the heater, we regulate the voltage to the motor. So about constant value even when there are disturbance. So meaning that when your system has many disturbance or your door, your windows open, the room temperature will be increased. So your system will try to maintain that temperature. So that is meaning lah, to regulate certain variable about constant value even they are disturbance. Something like level tank, when you use the water outflow and then the system will try to increase the inflow water to the tank, something like that. To force some parameters to vary in a specific manner. So sometimes we force the some parameters, something like voltage, current, to vary in a whatever that we need, some specific manner. So maybe your control can be manual or maybe automatic. What is manual? Manual bit, we human control the opening of valve. Human control the level, or automatic. We just set the temperature, your system will turn on and maintain the temperature. That is automatic. So control system can be manual, can be automatic. So can you imagine back what you have drawn last Monday, your system is manual control system or automatic control system. So also what is actually the block diagram that you can represent the system. You represent the system into blocks. Okay, so this is the example manual control. So we know that manual control or something that this is the level tank, there is level water out here and water in. So this is your eyes, human eyes that try to maintain the level of water. So your eyes see at this level, maybe your hand will be turned on the valve here. So when somebody use the water outflow here, so your valve will be turned on. Or maybe nobody use the water, this one closed, your valve will be turned off. So this is manual control. You manually control this valve. We manually, no electronic instrument needed here. So we manually control the level of this water inside this tank. So we maintain the level at H high. So we use manually. So manual control, if you check, is human aid control, operated constantly observe deviation and make correction when necessary by human, by the operator. So this is the operator lah, you here. Not consistent. You must focus. So maybe not consistent, the water may be increased, maybe lower, that's the set point. So the result will be not consistent. So if 100 of variables to be controlled, so how to control? You need more operators to handle the system. So to operate the system to be at the set point, That is the problem of manual control. So that is manual control lah. So from this we can from the manual control you can design to be a automatic control. So we can design the system now manually to be an automatic system. Okay. So how to design the automatic system? So we replace the human with machine. So everybody knows. So how to replace human with machine? Your machine must have sensor to measure the level, sensor to measure the temperature or transducer, sensor to measure the speed. That replace our human task. So you need controller. We need controller, computer, whatever, Arduino, Raspberry Pi, microprocessor, whatever. We program that one to make a decision. So we need controller to make the system automatic. And we need the actuators. Something like pump, valve, all the actuators that will be act accordingly with the set point. Okay, so in this case, if you have the liquid level system, that is manual system, so we can design to be automatic system. So you can design yourself, something like this is your tank. You have the water flow out here. So maybe you have this valve, water flow in. So in this case, you need sensor to measure the level. What is the current level of this tank? Current water level. So you maybe need a few type of level sensor: pressure type sensor, capacitive type level sensor, resistive type level sensor, fluid sensor. So you can get the signal from sensor. Electrical signal that represent the sensor, meaning that you have to calibrate your sensor. This is your voltage output from sensor, and this is the level. So you have the relationship between voltage and level. So at this level, so how much output that you get. So this voltage actually will be compared with your set point. This is your set point. You set level at H. We don't know, so maybe this one H. So at this point, what happened to the system? You compare your set point with the current level of this system. So this one will be the output is H minus H prime. So the output must be electrical signal. So this one set point we can change to the electrical signal, because the next component that you have may be controller, maybe amplifier, will be electrical components. So this controller output will go to your valve or maybe motor to turn on the valve or to turn off the valve, depends on the level of this tank. So your system from manual, now this is the automatic level control system. So you need the controller, or maybe you need amplifier to amplify the signal, or maybe you need some power amplifier to turn on your valve. It depends on this valve. Or maybe you have motor to control the speed of air, water flow, and so on. So any disturbance, this one we call disturbance. Somebody takes water flow out from this tank. Somebody disturb this level. So now the sensor will measure what is the current status of your water. We send the signal to the system. And the controller here will make decision where there is some difference between your set point and the current level. So the controller will send the voltage or power to your valve to turn on the valve, and finally the water flow inside the tank until H minus H prime equal to 0, meaning that the system at your set point, your result, your H level output here at your set point. So H is your set point, H prime is the current level. So when H equal to 0, H minus H prime equal to 0, so meaning that no control action here, meaning that your valve will be closed. Your valve will be closed. Okay. So this is how we can convert the manual system into automatic control system. So the idea is you must use sensor, you must use controller, and then you must have actuators to make sure that your system will be automatic system. Okay. Is there any question? Any question? No.
No.
Can you hear my voice?
Yes, doctor.
Very good. Okay, so the main control system components, actually we have discussed what we need sensor, we need controller, the brain of the control system, and we need the final control element. Final control element is actuators. Actuators is your motor. There is actuators. Final control element. Motor, your heater, whatever, your compressor, maybe if you have aircon, valve, so many more. So any final control element that drive your output, we call that actuators. So controller that make a decision. To compare the input and output, they try to make a decision how much power that we need to give to the motor, how much power that we need to give to the heater. So depends on the difference between your set point and the current output, the actual output and the set point. So the difference will be translated by the controller. So sensor, we need sensor to measure our current status. To measure the current status of the maybe level, maybe temperature. So we need sensor. Otherwise, we cannot measure physical signal into electrical. So we need sensor or transducer. Okay, so there is 3 components that we need. Okay, so maybe our system can be open loop or closed loop. So many system that you sketch last Monday, maybe open loop, maybe closed loop. Maybe manual, maybe automatic. So what is the open loop here? Open loop meaning that something that we give the input and the system will react with the input. Something like this. We give input, we have controller here, goes to the plant, so maybe you have the actuators lah. Actuator, your valve, your pump, your heater, actuators. Final control element and then the plant. So no measurement of the current status of the output. This is open loop system. So we just give the input, and then the controller decide, oh, we need to give the voltage to the actuators, and then your actuators drive your plant and you get the output. No measurement of your output, the current status of the output. If there is disturbance to the system, your output will reduce or increase. No measurement here. Okay, so this is, we call that open loop control system. Something like you have fan, you set the speed at level 1, 2, 3 until 5, but the system not measure what is the current speed of the fan. So there is the closed open loop system. So open loop system has no effect on the control action. So no control action is taken. Is the output not equal with the input? If the speed output of your fan here not equal with the input speed that you set with the system, no action taken. So that is the open loop system. Open loop system do not correct for disturbance. If you have disturbance, more dust to your blade and so on, no action taken. Okay, only open loop system, the output is not compared with the input. So this is very important. Your output not compared with the reference input. So just you give the input, you get the output. We are not measure the output. Is that same as your input set point or not? So that is the open loop control system. So any control system that operates on a time basis meaning that timer, we use timer, something like toaster. Toaster, you set timer 3 seconds, 3 minutes, 2 minutes, and then your system will heat up the bread and so on. But not measure the color, whatever, just based on the time setting, that is open loop system. So system that use timer is open loop system. So you can imagine your system, you have sketched the system. Is your system open loop or closed loop? What is closed loop? Closed loop, we measure back what is the output of the system, and what is the speed, what is the color of the bread, what is the temperature of your heater. We use sensors here or transducer, or we call that output transducer, because they measure the output. This one input transducer because from the set point, input set point. So for the closed loop system will measure the output, the current output, the actual output of the system, and then compare with the set point. So plus minus here is this one we call that summing junction. Summing junction, that compare the input and with the output. Maybe some this one subtract, subtract, but we call that summing junction. They subtract the input signal, meaning that your set point with the current output. So the error here, the result from the different, will use by the controller to give some input to your actuators. Actuators. Okay. Okay, so that is the closed loop system. So meaning that if you have disturbance, disturb your system, so many student, your room temperature reduce because you open the door, windows and so on. So you can get the output not equal to the set point, maybe increase, and then your system will be measure what is the current status of your output, and then compare with your set point. So your compressor will be react with the different temperature. So that is closed loop control system. So the difference between open loop and closed loop, the closed loop, we have the output transducer, or we call here is feedback. Feedback transducer. Maybe you can you get from books feedback, or we call that feedback control system. Some books use closed loop. Here is feedback control system. So if we refer to feedback control system, meaning that closed loop control system, so we have the transducer that measure the output status of your system and compare with the input to do some correction. Okay, so a few variables, a few parameters that you need to understand when we draw the block diagram of open loop or closed loop control system. So one thing is the set point. The set point is the input set point, setting of your temperature, setting of your flow. That is set point. So you have the manipulated variable. What is manipulated variable? Is output from the controller. So this value will be varies, depends on the difference between the input and the output signal. So manipulated variable that derive your actuators, your pump, your heater and so on. This is manipulated variable. Okay, and then this is your plant. Disturbance, any things that disturb your system, we can add disturbance to the system. This is the summing junction, meaning that plus here. And when you add to the system, you plus. And then control variable. You must know what is control variable, or you can get from the glossary from e-learning. I put a few glossary, the important terms that you must know. Control variable, meaning that something variable that we need the system be controlled, meaning that the output of the system. Output, this is the temperature. If the output temperature, mean control variable is temperature. If your output is level, your control variable is level. The actual level of your system. So process variable here, when you convert the control variable using transducer, then it's called process variable. So in control system, when you plot the block diagram, so the arrow here is very important to show the signal flow. The feedback and goes back here. So arrow is very important. So if you put arrow here, different with arrow to the summing junction. So a few more important parameters will be discussed later lah. What is here? What is the pick-off point that we call this here pick-off point? Meaning that you can take any signal here, or want to check this signal, you just take this signal. So you can tap any signal here. So we take this signal and compare with the output. You can put the summing junction or comparator here to compare your input with the output, or we call this one is summing junction. So the function is to compare the input signal with the output call process variable in this case. Okay. So you must know lah what is control variable. So next after this, we always mention that manipulated variable, control variable, input set point, output controller, output transducer. So you must know where the signal is, where the components in your system. Okay. Okay. For the closed loop system, or we call that feedback control system, we have input transducer. That is the major difference with the open loop control system. We have input transducer and output transducer. Okay, so this one is the major difference. And we have the output transducer. Open loop, we also have input transducer, but closed loop only have output compared to the open loop, they don't have the output transducer. Yeah, so output transducer measure the output response and convert into the form used by the controller. So meaning that basically into electrical signal. Yeah, so because all the components, the processor, the comparator, all the electrical components. So transducer will convert the output signal from your system into electrical signal. Okay, so summing junction. So this is the summing junction. Summing junction that you have something like this, plus and minus, we call that summing junction. To add the signal or subtract the signal. To compare the input with the output, we use this summing junction. So maybe plus, maybe minus. So it depends on your system. But in general, the feedback will be negative because we compare your input with the output. And then maybe another one signal here is actuating signal. Actuating is the difference between your input and your output. This is output from your summing junction. Your summing junction here. So this is, we call that error signal. You have the input signal. This one comes from the feedback. The difference, we compare using the summing junction, the input, the signal here we call error or actuating signal. Why actuating signal? This is the signal goes to the actuator, goes to the pump, goes to the heater. After you amplify, after you maybe filter the signal and so on. So we call that error signal or actuating signal. Okay, so closed loop component for compensate for disturbance. So meaning that if your system have some disturbance enter your system, so the closed loop control system will try to minimize the effect of the disturbance. So they try to make sure that your output equal with your set point. That is the function of the feedback, to minimize the error, to minimize the disturbance. If there is a difference between the two response meaning that your input and your output, the system derive the plan via the actuating signal, meaning that the output here, the actuating signal, to make correction, meaning that if the different temperature increase, so maybe your heater will be, the power to heater will be increased, to make sure that your set point equal to your output temperature. So this is the function of the actuating signal, to try to make a correction. If there is no difference, meaning that your input with your output is the same value. So meaning that error equal to 0. The difference here, the error here equal to 0. So the system does not drive the plant, meaning that no power sent to the heater, the pump will be of, so there is, meaning that your system achieve your desired output. So your output equal to with your input. Okay, so this is example. Actually we have done how to automate your level control from the manual to the automatic. So meaning that if you draw the block diagram, this is your set level point. This is standard. You can put input signal. So when we draw the closed loop, meaning that you need to put this summing junction, comparator. We call this comparator. To compare the input and the output signal. So you have controller, you have maybe amplifier, filter, whatever inside here. And then the output, this is your manipulated variable here. It goes to the pump, this is the manipulated variable. And then you drive your pump to fill in the tank, maybe here. So you have some disturbance, we can put here, disturbance. And what is the current status of your output? We measure back what is the current level here. So you need sensor to measure this level. Use the level sensor and we convert the level H into the electrical signal and we compare with your set point. We need this one electrical signal because the output will go to the controller, your microprocessor, your Arduino, your Raspberry Pi, and so on. This controller to make decision how much power need to give to the pump, to make sure that your output will equal with your set point. So in this case, if your set point is H and your current output is H here, so meaning that the error here is H minus H. The difference between your set point and your actual level. So what we need is H minus H must be equal to 0. So your system is very accurate. If your final output, your current level of your tank is equal with your set point, so meaning that your system is accurate. Otherwise, we have some error. Some error. Maybe you have different. So the error is the difference between your set point and the actual level of your current system. Okay, so from the open loop, you can convert to the closed loop and you can draw the block diagram and represent all the blocks with the component that we use. Component that we use. Maybe you don't know the actual specification of the component, but we know we need pump, we need heater, we need motor. So we need level sensor. Maybe you don't know what type of level sensor or temperature sensor, but we know we need the level sensor to measure the level. Okay, so this is the idea, the basic idea that you should know lah. So if you compare the input and the open loop control system and closed loop control system, so you can compare in terms of design. In terms of design, maybe closed loop, you have feedback control, you need more components, so maybe complex, the design. Open loop may be very simple. You just give the input, the controller and the actuator, the system will be run. So this open loop. So in terms of maintenance also will be reduced. So you discuss in terms of cost. Which one is more expensive compared closed loop and open loop? Meaning that more component, more transducer that you need, controller, need do programming, so maybe high cost. And then sensitivity. which system is more sensitive to the disturbance? So meaning that closed loop system, if you have any disturbance, the system will try to maintain to the output to the set point. So less sensitive to the disturbance, to the noise, disturbance, whatever lah. For the open loop, any disturbance, the system will follow the disturbance. Because we are not measure the current output and compare with the input. So you can see in terms of sensitivity of the system to the disturbance. With using the feedback system and without the feedback system. Okay, so this is the difference. Accuracy, which one will give more accurate output? Sure, the closed loop control system will get more accurate. They will try to minimize the error, the difference. So you can read here more explanation here. And then stability. Stability for the closed loop system is a major problem. Why we call that stability is a major problem? Because the system is always keep on changing, try to correct the difference. So meaning that if your system, we set the temperature at 20 degrees, your system will try to go to 20 degrees, but if any disturbance here, your system will be disturbed. But the feedback sensor will send the signal to the system, they try to do some correction. Some correction. So we maintain back to the set point. Any disturbance, they will try to maybe increase, your system will be try to minimize, so they will be maintained at the set point. So this one we call that this stability of the system. System may be fluctuate because we try to overcorrect the error. So compared to the open loop system no stability problem. Because any disturbance enter to the system, maybe your temperature may be increased, and then disturbance they reduce, they will maintain reduce, no correction will take place. So meaning that no stability problem here. But your result may be inaccurate. So for closed loop system, maybe they have the stability problem here, but the final output may be more accurate. Try to maintain at the set point. Okay, so that is different lah, stable or accurate or not. Okay, so you can see the accuracy lah, accuracy here. Okay, so some system, so maybe we can design with the combination of open loop and closed loop control to operate maybe alternately. Something like you have washing machine. You know the washing machine, the first part is to measure the level, how much water that we need. So that one is a closed loop system. So it depends on the weight, maybe they decide what is the level of water the system needs. So after they maintain, they get the level, that is closed loop, and you have the washing process. Washing process is actually is open loop system because they use timer. So timer in control system is open loop system. So maybe combination closed loop and open loop, the system become cheaper. So after making spinning process and draining process, all open loop control system. But the level itself, control level of the water is a closed loop process. So maybe one system is a combination of a few methods. Maybe open loop, maybe closed loop. So we combine that one, become a one complete process. Okay, so it can be done. Okay, open loop or closed loop. Okay, any question? Until
Doctor, can I ask about what is exactly the blend?
yeah,
I don't quite understand the concept of the blend. What is the blend?
the
Blend.
blank.
Blend. BLANT.
Blended. Ice blended.
What do you mean? Sorry. The sound is I can't hear it.
Chat. Can you look at the chat?
Wait. Plan. Okay. What is actually your plan? So we have the plan here. Is it a plan? Right?
Yes. Is it? Does it mean the transfer function, or is it a device, or what is it?
Okay. So something like if you have wow, where are you? You are driving?
No, actually, this is not me.
Oh, you playing game. So noisy.
No. This is someone else.
Someone else. Okay. Okay, so something like this. If you we take the example, maybe we have the level control system, correct? We have this one. And maybe easier. You know that level control system. So you
Yes.
have you understand this one. You have the input, and then you have the output. Maybe open loop or closed loop is okay. Yeah. So
Yes.
this is your controller. Controller, and then maybe this one you have motor. We use motor to pump in the liquid. And what we call here plant here is actually the process. That one include your tank, the water inside the tank, all the material that the plant. When we call plant, meaning that all your tank, your water inside, this is plant.
Oh.
So
Okay.
meaning that this one is this water tank with the liquid. This is plant. That's why when we measure, this is your output. We take here, actually we measure the level here, H. Motor is somewhere outside here. They pump in water inside the tank. Okay?
Okay.
So maybe you have amplifier, you have a controller here, and you have to compare with the input and what is the current level here. You need the transducer and compare with the input. But the idea
Thank
is
you,
you
doctor.
must know to draw the arrow. Arrow meaning the flow of the process.
Yes.
Okay. Any more question?
Thank you, doctor. Thank you.
So actually we have finished this part and goes to the a few example. Any question? Anyone? We go to the example. I'll check the example. If you have any question, not really understand the the concept, because after this we goes to the chapter 2, modeling. Okay, we see the example of the control system. I don't want to see from the slide, but we see from what we have given, what we share. Okay, no name. How do you represent your icon? Okay, we can choose which one you want to choose. We choose here. So maybe car. You have this car. What actually you mean that you want to control the speed, correct? Muaz, are you here? Muaz, Muhammad Asri. Muaz. Where Muaz? Muhammad Asri.
He replied in the chat. Yes, he said yes.
Okay. So you unmute or unmute. Are you Muaz?
Siapa yang
Muaz? Can you explain actually what actually you want to represent here? Muaz, you are around. Just unmute your microphone. Can you explain this one? You want to control the speed of car. So you have the pedal here, you have engine, you have tire, speedometer, and display. So actually this system is manual or automatic control?
Manual tu.
Ya, where in Muaz?
Hello, testing. Hello. Hello.
Ya.
Actually, I send two example. I try to send open loop and closed loop.
Ya, okay.
But in this example, I forgot to put. I don't know how to make it automatic closed system. So actually, I want to connect it to the cruise control.
Cruise control.
Yes. So the car system will maintain the car speed. We are using cruise control.
Can you see?
No.
No. Gray screen.
Stop sharing. I'll share again. Can I?
Yes.
Okay.
Where is that one? That's right.
Okay.
So
First,
meaning
we push the pedal, and then the car get the input and make the tire move. And at tire, there is a speed sensor to monitor if the speed where
The current speed lah.
the current speed. Okay, then the current speed will give the reading to the driver. So if the driver didn't put the cruise control, so we can make it manual closed loop. If the driver put the cruise control to 100 kilometer per hour, so it can be automatic closed loop system.
But this one, this also closed loop system, right?
Yes, the closed loop, manual closed loop.
Manual control but closed loop. What closed loop? You closed loop in this case, otherwise they become open loop here. You just
I don't know how to connect to the input. I don't know where to put the arrow.
yeah, this one is the speed. Speed
Yes.
meaning that your eyes see what is the current speed here. Your target
yes.
speed, sorry, your target speed. You want to maybe 100 kilometer per hour, and then
Yes.
you all these component will be inside here lah. All these component. And the speed sensor actually is not the feedback. If you design as open loop, it's not the feedback. Just speed sensor and they display the reading, correct?
So if I stop at the reading, it will be open loop.
Yeah, this one become open loop. But if your eyes monitor the current speed, this is
So
not
I
the
can
sensor.
put it feedback.
Yeah, this feedback. Why? I don't know. So we compare here. We compare what is the current speed. Current speed. Okay, but it's still manual, but closed loop system. Closed loop because you monitor the current speed and compare with the desired speed that you want. So meaning that sensor here is your eyes. Correct? Your
Yes.
eyes will monitor this one.
The
meter. Your eyes monitor the reading of the meter. So this is manual control but closed loop. But if you just punch the pedal here without have any desired set point, meaning that any speed, this is become open loop lah. But you have the desired speed and you try to maintain the speed by viewing this one, they become the closed loop. Another one automatic using the cruise and so on. This one automatic lah. You don't do anything, correct?
Yes.
The sensor itself will compare with your whatever you set here. So this system can be manual, can be automatic, can be open loop, can be closed loop. Depends on how you design. You want to design closed loop, it become closed loop and automatic, can be. If you want to design as automatic and closed loop, so you can design depends on whatever you put here inside this block.
So I have a question. If I make it manual closed loop, where can I put the eye at this diagram?
Eyes, this one lah.
Or in that box?
Eyes. I don't know what it is like. Eyes, eyes. Your eyes will monitor, but your controller here is your mind. You mind make a decision.
If I make it automatic, also put it in the red box.
Yeah, this if you put automatic, this one become feedback sensor. Speed sensor. The speed sensor, your system will compare the cruise system, whatever, and then you have the controller. You are not doing the to control the pedal and so on, but then one become automatic lah. Okay, so any more?
Okay.
Any more? Phone. How you want to describe this phone? Phone. You want to discuss about what? Phone, which volume setting, brightness setting. It can be automatic or manual control. You control manually, can be manual. The dim, the brightness, if you want to the handphone automatically control the brightness, they will be automatic. So the idea is what is the input parameter, and what is the input. You must check what is the input. You need, because many parameters involved here. Input, what type of output that you need. You want to control volume, you want to control brightness, maybe you want to control the voice control one. So many function now. So if you can draw the block diagram, any function that involved in your phone. Okay, who is right the handphone? Okay, lamp table here. If your lamp table is you have switch, switch, and then you have switch here. Why? And then this one is your lamp. I don't know what happened to this one. Long time no use. What happened? Okay, so maybe you have the light, your bulb here, okay, your bulb, and then finally the output is the brightness. If you can control the brightness, you set the brightness, maybe you can control switch, or they will follow the environment brightness, they become automatic, or maybe closed loop. Or you cannot control, you just put this switch open on and off, this one become open loop. Open loop lah, just switch on or off, the lamp will be turn on or turn off. There is open loop. But still automatic control. But open loop system. Okay? Syazwan, Muhammad Abdul Nasir. Hydraulic jack, is that automatic or manual? You want to the certain you give input.
Manual.
Manual. You give input, and then you get the output high and so on here. Increase the high, whatever. Up and down, maybe become closed loop. But if you have sensor that measure the current height and compare with the input here, what is the height that you need, they become the closed loop system. Become closed loop system. So you need the certain height, You need the feedback sensor, become the closed loop lah. So depends on you. What type of hydraulic check here, manual or automatic. Also microwave, you want to control heat maybe become automatic. But if you only control using timer, the timer itself is automatic but open loop control. Okay? Is there any question? This one printer, what do you mean printer? Printer, you just the idea is you can draw the process. Yeah, you draw the process. What do you mean? What is the input? What is input that you mean? And you put the paper there, and finally they come out with the text. But if the system is your printer not measure the quality of the paper and so on, this one become open loop. If the printer can give you the best quality, whatever you want, based on your set point, that is the closed loop. Okay, and any question? This one car, the same car, rice cooker, is it open loop, closed loop?
Open. Code.
Open.
Any time
Open.
use timer is open.
Sebab ada timer. Code.
This one fan also open loop.
Yes.
Is that the system measure the current speed and compare with your set point, that is become closed loop. Okay, so this one, what do you mean? Calculator.
Close loop.
Close.
What do you mean by close?
Tak ada timer. Code.
I'm confused because I think it could be because you have to insert the values, but which to me it's manual, but it's the calculation is done by the calculator itself. So would that mean it's automatic?
Yeah, automatic control. The automatic. But you must know what is the output that you need. Is the output can be measurable?
It's not a machine.
Is there physical parameter from the output?
This is not a controller.
Meaning that this is the system itself, but no control action. This is just calculation. Calculation. This one also calculator. What do you want to explain calculator? To be a control system. So for this course, our control system will involve any physical parameter. Any physical parameter. What is physical parameter? Learn from the instrumentation. Physical parameter that we need to control something like flow, pressure, level, level, temperature, displacement, something that we can measure. We want to control that kind of current also can, voltage also can control. That involve the system that control the physical parameter. Something like water heater. Water heater is open loop or closed loop system?
Depends on the price.
Oh,
Depends on
Water
the
heater
price.
majority
I think
is
it's open.
closed loop system.
I think it's close. You need to maintain the
Close.
temperature.
Why close? You set the temperature here. Basically, we want to use, they try to maintain the temperature, maybe on-off control, use the different type of controller. The expensive one maybe using AI technique, but the cheapest one using on, maybe on-off. Where over the limit, they will off. They below the limit, they will on. So still control system. But controller itself may be cheaper. On-off something like switch.
So it is closed, right?
Yeah, closed loop system. Still automatic. Water heater. This one also closed loop system. You have the feedback sensor, the fluke sensor here to fill in the tank and so on. So you can draw the block diagram to represent the system that you have catch here. So please draw the block diagram and update this drawing. So choose one process, whether you choose the open loop or closed loop also can. Become a manual or automatic also can. So you draw back the block diagram for this system and add add some more block diagram in your this paper. Then identify what is the input parameter, what is the output parameter, any involve the controller, what is the actuators, meaning that you need valve, you need heater, you need pump or whatever. Fan is open loop system. No correction, no feedback. So maybe aircon is closed loop system, basically closed loop. This one, what is this? Laptop. What do you mean, laptop to control the temperature? What? Or what? I don't know. Very cute.
CD.
CD. Laptop Pro. This one. Is that you have the shampoo? Shampoo will be.
automatic shampoo.
Yeah. I never use this one. How your automatic shampoo will be up top of your. You have sensor here.
Balik bawah tu.
What the function of this sensor? So make sure you think again this one and make sure that the system become logic and can get somewhere. Hair dryer, what is hair dryer? Some hair dryer may be open loop.
Open.
Just
Closed
switch,
loop.
switch on the. But if you have hair dryer that measure the current temperature of the airflow, that become the open loop. It depends on you. Okay.
Oi, dah habis.
Okay. So you draw the block diagram to represent your system and make sure label all the components, the sensors, the feedback, open loop or closed loop. So you choose one and post again, delete or you can post again to the Padlet.
Doctor, can I ask you about my drawing if it's open loop or closed loop? Because actually I'm confused.
Which one?
It's up.
Huh?
Up.
Curtain.
No. Up. Still up. Yes, more. Yes, this lamp.
Lamp. This lamp.
Mm.
The function of this lamp, you just on, they will on.
On and off.
On
Mm.
and off. On and off meaning that there is open loop control system.
But it maintains the brightness level, isn't it?
is that they try to because for LAMP you have something like switch here, right?
Yes. Maybe certain input voltage controlled by a transducer greater than some voltage, it means on, and less means off.
Yeah, but in general, you on and off, you just disconnect and connect the current flow, correct? For the system. This is open loop. Unless you have the some sensor that measure the brightness, they measure the brightness, and then you compare the setting of the brightness, meaning that the system will control the level of current.
So here there is no controller, or there is controller?
If you have if your system, if this one have controller, that become a controller, meaning that this one switch. This is switch.
Switch is a transducer, right?
Switch is your input. Your input should be 1 or 0, correct? On or off.
Yes.
When you switch is on, they become on. On meaning that the light is on, switch on. Unless you have the sensor that measure the brightness, then compare, and this one is not switch, maybe the level of current flow. When they see the environment brightness compared to your lamp, they will increase the current flow or reduce the current flow. It can be, if you want to draw that kind of lamp, you can draw the complete set of closed loop brightness. This is the brightness lamp lah. If you just put on off, the switch will be on and off, and it's a normal lamp, normal bulb here. This is the open loop. Okay. This one solar cell and lamp. I think the same function. Solar cell just to represent your supply to your lamp. Okay. So TV, what do you mean by TV? Television. You plug in. You want to control the volume, or you want to control the brightness, the color, the combination of color.
Control boringness.
So depends lah. You choose one.
Remote control.
The remote control is there. So you must draw the function, how the signal goes to the TV. So from remote using the whatever type of remote signal, so you can control the volume as well. Okay. So actually, I have one. You can see from Padlet, we have one. I just put one statement there that whatever that you need to update your diagram. Why not here? Not here. Okay. Yeah, I think you can see from the Padlet. So you must mention what is the input and output, what is the component that you draw back the block diagram and so on. You can check from the any question?
Doctor, I have a question.
No, ma'am.
I have a question.
Okay.
In Padlet, do we have to draw the box and label, or we have to draw component and label?
Label? What do you mean label?
Labeling.
Labeling. All the signal that you know. Labeling,
So,
what is the output.
We have to draw component and label the component, or we just draw the box?
draw the block diagram,
Block diagram.
label the components, make sure the block itself you must put the maybe heater to whatever amplifier or pump, and then the plant itself you mentioned plant. What is your plant? Is your TV? Is your tank, level tank? Is your lamp? Lamp is your plant. This is the plant itself.
Oh, okay. Understand.
Okay. So I think we stop now because just one section we finish by next week. So you can continue with the Padlet and fill in draw back the not draw the system, the draw the block diagram of your system. It can be you must mention open loop or closed loop, automatic or manual, and label all the components and the signal. Okay, so you can post to the Padlet. Any more question? You don't have any question, we can stop here.
Thank you, Doctor.
No
Okay.
question.
Thank you, Doctor.
No questions, doctor. Thank you.
Okay.
Good doctor.